Have you ever wondered how we actually know what's going on with the weather? In Nacogdoches, Texas, pilots use a system called Awos to learn more about the weather. What exactly do I mean when I say Awos? Awos is an acronym that stands for Automated Weather Observing System. There are 6 different variations of Awos, but Nacogdoches uses an Awos 3PT, also known as Awos-C. At first glance, the Awos might not seem like much on the airfield, but trust me, there are many different components that go into analyzing the weather. There's a lot to learn about how the automated weather observing system works, so let's see how each instrument works together to produce a weather observation for pilots. Let's start with the ceilometer, an instrument that uses light beams to measure the heights of clouds. The ceilometer shoots a laser beam up to a cloud and measures the amount of time it takes that light to travel back. It determines the height of the cloud using this formula and sends that information to the Awos's computers. The ceilometer also has the ability to tilt up to 12 degrees to get more accurate readings. The rain gauge is used to detect precipitation on the airfield. Taking a closer look at its components, we have the main funnel, a central tube, and our 2 drain pipes to either side. On the tube, we have a magnetic switch that swings back and forth in between 2 metal reeds. This completes a circuit, and the gauge tracks the pulse of each swing. Attached to the magnetic switch is a tubular dump cone. The shifting weight of water in the dump cone swings the magnetic switch. Inside the central tube, there's a water divider that catches precipitation and flips the switch. The rain gauge sensor detects heavier precipitation when the switch moves back and forth more rapidly. The present weather sensor uses multiple instruments to measure weather conditions for the Awos. The transmitter houses an infrared lighting component. The hood heater melts any ice that might get in the way. There's one for the transmitter and one for the receiver. The luminance sensor detects light. The mini rain sensor detects moisture, so it sees the difference between bugs and precipitation. And the thermometer tells the hoods when to start heating. The transmitter sends out infrared light into a volume of air. It hits particles, and those particles reflect back to the receiver. The receiver can then make a decision on the quality of visibility for pilots and send that information to the Awos computers. All of the smaller components of the present weather sensor allow it to gain the most accurate description of what the atmosphere looks like. This is helpful for pilots because some pilots don't have the proper experience requirements to fly in poor visibility, helping them determine when not to fly. The most iconic thing about the Awos is probably its orange and white striped tower, which houses many important instruments for the weather system. The barometric pressure sensor detects the density of air molecules in the atmosphere and helps pilots determine how high off the ground they're flying. It's connected directly to the data collection platform. The pressure port feeds outside air into the barometric pressure sensor inside. The Nacogdoches barometric pressure sensor is different than what you would see in a textbook. It's easier to understand using this illustration. The sensor has 2 small metal plates inside, and a conductive material in between those plates. Imagine that the material is a lot like a sponge. Like a sponge, the material can be compressed and decompressed with pressure. The plates are going to send a current of electricity through the material. Imagine that current like a current of water through a hose. When there's a lot of pressure pushing on the material, it squishes like a sponge. If you squished a sponge with your hands, water would travel faster through it because there would be less distance for water to travel through. The material works the same way. When it's shortened, the current travels faster through it. And when the density of the air molecules around the plates don't compress the material, it takes a longer time for the current to travel through. The times are calculated and translated into barometric pressure by the computers. The motor aspirated radiation shield detects dew point and temperature in the surrounding air. The Mars system has internal components that is covered by a shroud to help regulate heat. Components include a fan, filter, relative humidity sensor, temperature sensor, sensor data plug and wire, and vents are located by the fan. Let's discuss the relative humidity sensor. It measures humidity similar to how barometric pressure was measured. Inside the sensor there are 2 small plates, with a conductive material in between them called a polymer. We can think of the polymer like a sponge, but this time the sponge pushes the plates, not the other way around. Here's how it works. The fan spins and creates a vacuum near the main opening. This draws outside air in. The air travels through the filter and over the polymer. If the air contains moisture, it gets absorbed by the polymer, and it pushes the plates farther apart. With the expanded polymer, the current will take longer to travel through the conductive material. The time is measured to calculate moisture in the air, and the information is sent to the computers. The Nacogdoches Awos doesn't have a mechanical wind sensor, but an ultrasonic one. This means that it has nodes on the ends called transducers. They send out ultrasonic sound waves to each other and act as transmitters and receivers. Two nodes are lined up north to south. The nodes transmit sound waves to each other at constant frequency. So if a wind was detected, it would take longer for the sound waves to reach the receiving end if they were facing the headwind, and they would travel faster in the tailwind. The ultrasonic wind sensor would detect this change in speed and be able to calculate the wind speed, and by detecting which transmitters and receivers are affected, it gives you the wind direction as well. All of these sensors would have no purpose if their information couldn't be transmitted to pilots. The computing systems do just that. The computing systems on the Awos receive, encode, format, and transmit this information to pilots. There are two computing systems on the Awos, the data collection platform and the central data platform. The data collection platform collects all of the data inputs that the sensors send it. As it intakes the raw data from the sensors, it uses government-provided algorithms to compute and code the information. It then sends it to the central data platform. The CDP double-checks the information for errors and organizes it into a usable form, such as verbal radio enunciations and METAR. The CDP can then broadcast this information to pilots. The ultra-high frequency radio is a lot like a megaphone for the CDP. It sends out the organized information to pilots. A pilot would first hear Nacogdoches automated weather observation, then the time that it was given. The term auto indicates an automated source. Winds from the UWS, how many miles of visibility, precipitation from the rain gauge, obstructions to visibility, ceiling height from the ceilometer, temperature and dew point from the Mars, and altimeter setting from the barometric pressure sensor. Another pro for the Awos is that it is paid for and maintained by the government. This makes it a cost-effective option for Nacogdoches when compared to other weather observation systems. The con to that is that when a system goes down, it is up to the FAA's schedule to make repairs. And that means sometimes the weather reports can sound like this.
Nacogdoches Regional Airport, automated weather observation, 0414, Zulu, wind 09er, 0 at 03, visibility missing, sky condition overcast, 200, temperature missing, dew point missing, altimeter 3021, remarks, density altitude missing, present weather information not available, freezing rain information not available.
Well, I guess you get what you pay for. Hopefully they can fix that soon. The Awos at Nacogdoches Airport is an important tool that pilots use daily. Weather observations give pilots an idea of what's going on in the air. Now you know how weather information is collected and broadcasted to pilots. The Awos is a complex system, but maybe it's not as complicated as it seems. Thank you for watching. I hope you learned something new today.